Hello, my name is Zachary Grant. I'm the manager and director of the Sustainable Student Farm at the University of Illinois Urbana-Champaign. Today, we are going to go over the presentation, Scheduling Succession Plantings. Today's objectives are the following. Learn the basic concept of what succession plantings are and how they work. Learn how succession plantings fit into the big picture of a growing season. And finally, to review a basic spreadsheet planting plan and how successions might fit into it. So what is a succession planting? There are a number of concepts that define a succession planting. It could be as simple as following one crop with another crop. This could be the same crop in a different spot at different times, like leaf lettuce planted in different beds but a week apart, or a different crop in the same spot at a different time, like an early season crop of radishes that is harvested to make way for a later planting of cucumber, also known as double cropping. Another example would be the same crop in the same spot but with different maturity dates. The classic example of this being different varieties of sweet corn planted in the same bed but with different maturity dates. For some crops, succession plantings are essential to have a continuous supply throughout the growing season. You might be wondering, what's the difference between succession planting and intercropping? Intercropping is when a fast-growing crop, such as lettuce, is planted between rows in the same bed as a slower maturing crop, like tomatoes. The lettuce is harvested before tomato plants require the space to complete their maturation. This can be complicated to plan on a large scale. For the sake of this presentation, we will not discuss intercropping in detail. However, intercropping is frequently done in high tunnels and in home gardening settings. This is an example of succession plantings in a fall high tunnel at the student farm. The baby salad green crops on the right were planted 7 to 10 days earlier than the crops on the left. You can clearly see the difference in size. With baby salad green production, where multiple species of leafy greens are harvested to make a final mix, it is useful to plant fast-growing greens later than slow-growing greens. In the above picture, the slower-growing leaf lettuce and spinach ingredients are planted 7 days earlier than the faster-growing brassica ingredients, like arugula, mizuna, and red Russian kale. This enables the finished mix to have the same size leaves. Here's an example of intercropping in a home gardening setting. Leaf lettuce is planted with members of the brassica family. The lettuce will be harvested and cleared before the brassicas need the space to finish their maturation. Although this could be done on the large scale with planting equipment, this can complicate already complicated vegetable planting schedules. There is promise for intercropping in smaller high tunnel settings. Let's review some basic principles of succession planting. One basic principle states that you should plant seeds every 1 to 2 weeks during a seasonal planting window for veggie types that have a short harvest window. Examples of this include beets, carrots, radishes, other root crops, lettuce, and in some cases cucumbers, summer squash, and bush beans. Another principle is that you can plant transplants and seeds of the same vegetable at the same time, either in the same bed or in different beds. An example of this would be beets that you start in multi-blocks in the greenhouse as transplants. When those multi-block transplants are put in the field, you could simultaneously do a direct seeding of beets, either in the same bed or a different bed, to be harvested after the transplanted beets. Here is another picture of a high tunnel at the student farm, but this time in mid-March. As you can see, the plantings are a week apart in their maturation. Again, the faster growing salad green ingredients are planted a week later than the slower growing greens, so the leaves are the same size at harvest. So one full succession planting for the baby salad green mix takes 2 weeks of actual planting. We plant 2 100-foot beds per succession in order to have a manageable and predictable continuous harvest. Here is a bed of multi-block beets transplanted 3 rows on a 36-inch wide bed at a 6-inch in-row spacing. A direct seeding of beets the same day as the transplanted beets in the picture would give a staggered harvest of beets, essentially giving you the same succession effect as direct seeding two different plantings of beets at two different times. This could be a beneficial strategy if you can only get into the field to plant on one particular day over a week-long period due to heavy rains. Here's a picture of transplanted leaf lettuce in 3 different successions. As you can see on the far left of the picture, there are leaf lettuce plantings that are bolting and going to seed. As you move to the right of the picture, you can see leaf lettuce that is ready to harvest, and in the center of the picture are newly planted leaf lettuce transplants. Transplanting leaf lettuce is a strategy for having leaf lettuce in the warm summer months where leaf lettuce seed would not germinate in very hot soils via direct seeding. This is coupled with overhead irrigation to ensure transplant survival and growth. Here is a chart that has recommended succession intervals for direct seeded crops and transplanted crops with their corresponding greenhouse seeding times. There are many charts like this available on the internet and elsewhere. I've listed some in the resources at the end. You should compare multiple charts to see what succession intervals work best for your farm and climate zone. As you can see, some of the quick-growing crops with short harvest windows have the recommended 2-week intervals for succession plantings. Others, like cabbage and rutabaga, have longer succession intervals of up to 4 weeks. Although for long, warm-season transplanted crops like tomatoes, there is only one recommended planting, these could still be broken up between 2 plantings a week apart or 1 planting with tomatoes of different maturity dates. You could also plant some tomatoes of the indeterminate variety that have a long harvest window with determinate tomatoes that have a short condensed harvest window. Sometimes, succession plantings are forced upon a grower due to weather. At the student farm, our outdoor tomato plantings are a week apart to account for unexpected weather conditions. We have already touched on the succession planting principle of planting early, mid, and late ripening varieties of a vegetable at the same time in the same spot. The classic example being multiple varieties of sweet corn, dent corn, or popcorn planted at the same time but with different maturity dates. Of note, for corn planting in particular, is that super sweet varieties need to be separated either in maturity date or distance from sugary enhanced or synergistic varieties to avoid cross-pollination and the spoilage of the super sweet characteristic. The same is true of sweet corn varieties separated in distance or maturity dates from dent corn or popcorn. This succession planting principle can eliminate the need to separate corn by distance. We have also touched on the principle of following short-season vegetables with long-season ones, like following lettuce or radishes with tomatoes in the same spot. Here is a field at the student farm in the spring. We have head lettuce transplants planted at the same time but with different maturity dates. This way, with one planting, the harvest period can be extended over a longer period of time. Not only do we plant lettuce varieties of different maturity dates at the same time, we also do these plantings at different succession intervals of 2 to 3 weeks apart. In addition, as the succession plantings progress into the warmer months, we adjust the varieties we plant to those suited to growing in warmer conditions that resist bolting. This is called a lettuce planting program. There is a link to such a program in the resources. Here's another example of a short season quick crop planted with a longer season crop in the same spot but with different harvest times. This is a classic example of planting radishes and carrots at the same time. The radishes will mature and be harvested before the carrots need the space to complete their maturation. A final couple things to think about with the principles of succession planting. In thinking about the longer-term rotation plan for your farm, it is important to keep good records and make maps of where you are planting things. This way, you can avoid planting vegetables from the same family in succession. For example, you should follow broccoli with beans and not another vegetable from the brassica family. This can be tedious, but is an important part of the record-keeping process for your farm. And finally, we have already touched on the idea of using heat-tolerant varieties in the spring to extend harvest into the warmer months and avoid premature bolting. This isn't as big of an issue for fall plantings of things like broccoli and head lettuce as it is for planting these same varieties in the spring. Now that we have learned the basic concepts of what succession plantings are and how they work, we are going to move on to see how succession plantings work in the big picture within your farm systems and the growing season. Succession plantings fit into a farm system in order to provide a continuous, even supply of vegetables throughout the whole growing season. Some things to think about when incorporating succession plantings are that you want to avoid planting too much or too little of a given vegetable. They can be useful for filling space gaps in beds or fields of minor crops after the major crops are planted. Not all crops are going to be succession planted. Some crops like indeterminate tomatoes and peppers can be planted once for an even supply throughout the whole growing season. However, some crops need several plantings for a continuous supply, like many of the examples we have already covered, such as lettuce and radishes. It is also important to remember that the length of time from planting to harvest varies according to the temperature and sometimes the day length. Cauliflower, for instance, does not complete head formation until after the day length begins to shorten. It is important to keep good records of when you're planting and when you are harvesting. It is also useful to get information from other growers in your area so you can fine-tune these planting dates to help make your succession plantings more successful. We are now going to cover a few succession planting strategies. Feel free to experiment with any number of these. When just starting out with succession planting, the most important thing is to keep it simple. Some of these strategies include the rough plan, where you plan every 10 days, 2 weeks, etc., the no paperwork method, sowing several varieties on the same day or different seasons, planning the first and last sowings, then filling in the rest, planning a sequence of sowings using the tables and graphs based on your farm records. Then finally, we'll briefly touch on using growing degree days for planning succession plantings. The rough plan is the most basic succession planting strategy. In this method, a grower would essentially use charts like the one we have previously seen. From these charts, you can pull recommended succession planting intervals. Based on the above chart, an example would be planting arugula every 2 weeks during the direct seeding planting window, or planting broccoli every 3 weeks during the greenhouse seeding window. This is a very flexible strategy that can be utilized during the respective direct seeding windows or greenhouse seeding windows. A grower can later fine-tune these succession plantings based on farm records. I have listed some basic charts like this one in the resources, as well as a link to find similar charts for high tunnel plantings. The no paperwork methods of succession planting involve using personal experience, anecdotal information, and other similar information from vegetable growing resources. Examples of this method include sowing another planting of sweet corn when the previous crop reaches 1 to 2 inches in height. Another example would be seeding more lettuce when the previous crop germinates. Yet another example would be to plant more beans when the first plants start to straighten out from the hook stage after emergence. The nice thing about this method is that you can do it on the fly without any planning. Use these methods only for tried and true information or your personal growing experience. In addition, this method will have heavy variability based on growing conditions in a particular season, so it would still be helpful to keep records of when and where you planted the sowings for future reference. We have spent some time already on the next succession planting strategy. It is worth revisiting, though, to emphasize that this method works really well for vegetables such as sweet corn, lettuce, and even broccoli. Again, sowing several varieties on the same day or in different seasons has two basic components. The first, if you're planting on the same day, such as sweet corn, Varieties need to have different maturity dates so they can be harvested at the different intervals. In this example, of 3 bicolor, sugar-enhanced, and synergistic forms of sweet corn, all have 3 different maturity dates, all more than a week apart. This one planting on the same day will allow 2 to 3 weeks of harvesting from one spot. And second, planting several varieties over different seasons, either on the same day or in succession plantings. Johnny's Selected Seeds planting programs, which there is a link to in the resources, has information about planting programs for lettuce, broccoli, and other crops. The basic concept to remember here is that as you move from spring to summer, different varieties do better in warmer conditions and can thus extend the supply of that vegetable. This next method is the system that the student farm uses the most for planning its succession plantings. It has a few basic components, and in the next slide I will illustrate a useful spreadsheet to help you with this method. The first thing you need to do is figure out the first spring planting date for your crop. Most growers are pretty keen at finding this date by planting as soon as possible in the spring for some cold-hardy crops. But more frost-sensitive crops will depend on the last frost date for your area. It is also important to remember that with frost-sensitive crops, you don't plant too early, even if there is a sudden warm spell in the spring. Next, you need to figure out the last worthwhile planting date for your area. Utilizing the spreadsheet in the next slide is useful for this. To do this by hand, you can count backwards from the first frost date by the corresponding maturity days for the given crop. You need to factor in an additional 14 days for slow fall growth and add another 14 days for the frost-sensitive crops, unless you're using season extenders like floating row covers. For some crops that thrive in frost conditions, you can add another 30 days to the first fall frost date, and then count backwards with the corresponding maturity dates for that crop. This is how you arrive at the last worthwhile planting date for your area. Finally, using succession intervals from the charts we've discussed or other charts, you can fill in the respective succession planting dates between the first and last sowings of a particular crop. The Johnny's succession calculator on the next slide is very useful for this. Here is the succession planting spreadsheet calculator developed by Johnny's Selected Seeds. We will go over an example of this in the actual class in February. For now, feel free to experiment with this calculator that you can download from the Johnny's website for free. For this discussion, I will just highlight some things to think about when utilizing this calculator. The first thing you need to do is enter the fall frost date for your area, including the year. You can see it in the top left corner. For 2013, I entered October 15th, which is a pretty safe bet. Once you've done that, you can use the succession intervals for different crops that Johnny suggests, or fill in your own based on your experience or another chart. You can also adjust the days to maturity depending on what variety of the crop you are growing. If you are familiar with Excel and comfortable with this spreadsheet, you can adjust the final planting date formula as well by clicking on the cell and adjusting the formula in the formula box. They already have pre-formulated equations for different types of crops, but feel free to play around with it. Just make sure you know what it is doing before you make a planting plan based on it. You can then pull information from this spreadsheet and put it into your master spreadsheet for your planting plan, if you are using a spreadsheet for your master planting plan. This next succession planting method is a very specialized and complex method that can only be utilized after collecting information from each crop over several years. I've adapted this discussion from Pam Dolling's slide set you can find in the resources. This is a simplified example, but it can illustrate how record keeping can help you fine-tune your succession plantings. You need to collect 3 basic pieces of information from each succession planting for each crop over several years: the planting date, the date of the first harvest, and the date of the last worthwhile harvest. With this information collected in a table, you can plot a graph for each crop with the y-axis as the harvest date and the x-axis as the planting date. By drawing a best fit line through these points, you can start with your first planting date for a given year and find the corresponding expected first harvest date by following the lines that intersect with your best fit line. The same can be done to find the start of the last worthwhile harvesting date. accounting for time after that date to harvest before the first fall frost or whatever your harvesting interval is for a given crop. Here is a graph based on several years of tracking harvest dates and planting dates for summer squash. The points are plotted into a solid line graph. You can then draw a best fit line, trying to touch as many of the data points as possible with as many data points above the line as below the line. In this example, I just applied a regression equation to this graph to illustrate this. In Pam Dalling's slide set that I based this discussion on, she doesn't emphasize whether a regression equation line, like I put on the graph here, is better than a hand-drawn line that she illustrates in her slide set. With this line, you can trace up from your first planting date for a crop, then over to the left to the y-axis to find its corresponding expected first harvest date. The opposite can be done to find the last worthwhile planting date, based on the beginning of your last harvest interval. You can trace over from the y-axis to the best fit line and down to its corresponding planting date. You now can take that harvest period and divide it into whole number segments according to how often you need to have a new planting for a continuous harvest. In the summer squash example, you will have discovered a first harvesting date of May 19th and the beginning of the last harvest interval for the year as September 24th. In subtracting these days, you will get 128 days. If you divide this by a whole number, say 4, you will get a 32-day harvest interval between the beginning of each harvest. Based on 4 harvesting intervals of 32 days each, that would give you 5 planting dates. This is illustrated by the third bullet point, with the last interval to frost being the last harvest interval. You can now add the 32-day interval consecutively to the beginning of each harvest interval until you reach the beginning of the last harvest interval, 9/24. You will come up with the harvest interval dates of 6/20, 7/22, and 8/23. Now that you have those harvest dates, trace over from the y-axis to the best fit line in the graph and then down to the x-axis to find the corresponding planting dates for each of those harvest intervals. You will note that those planting intervals are about 30 days apart, which is usually what is the recommended succession interval for summer squash. This is an advanced succession planning strategy and should only be used after a few years of collecting data. In some ways, this method is good for checking to make sure your succession planting intervals match up with recommended intervals. Growing degree days can also be utilized to plan succession plantings. A growing degree day is a measure of heat accumulation. They are used regularly in insect management and in sweet corn succession planting. They could be used to schedule planting dates for successions in other vegetables, but there is not a lot of research yet outside of sweet corn. Growing degree days reflect actual conditions going on in a given growing season. They are a cumulative parameter. You utilize a base temperature, 50 degrees is common, but varies from crop to crop. Each day above the base temperature threshold, growing degrees accumulate. The equation is the average of the max and min temperature for the day minus the base temperature equals the growing degree days for that 24-hour period. If you want more information about growing degree days, there are plenty of resources online. Before we move on to a spreadsheet example, I would like to summarize the simplified big picture of succession plantings. You need to start with the major crop categories for your planting plan first. Then you can look for space within your plan to fit in more successions. This might be more successions of minor crops such as beans, or divided major crops into smaller succession plantings within the respective planting season. We will look at this in the next slide. Here is a master planting plan spreadsheet for the farm stand at the student farm. We will go over an interactive version of this in class in February. For now, this is just a preview of how it works. If you want to mess around with an example of this, send me an email and I'll send you a copy. It starts on the left with the crop list in alphabetical order. As you work your way to the right, there are more columns that have information regarding the number of weeks a crop is brought to the farm stand, how much per week is brought, the selling unit, total units needed, the row feet, total bed feet needed, is it direct seeded or transplanted, number of transplants needed, and then the number of 200-foot beds needed, and so on. Then it gets into some real relevant information for succession planting in particular, such as greenhouse seeding dates, transplant growing days, hardening off dates, field transplant dates, days to maturity, and first harvest dates. For direct seeded crops, there are field plant dates, days to maturity, and first harvest dates. There are equations embedded within each column that change as you enter in certain information in other columns. Again, feel free to customize these equations to your farm, but make sure you know what the equations are doing before you change them, or else it could throw your whole plan off. You will also notice in the crop list on the far left that I've already added in some succession plantings to the major crop list itself. Bush beans is an example of this. Those 3 plantings of bush beans are likely the only succession plantings of beans we will do for the farm stand the whole season. With other crops, like head lettuce for example, I have an early and late category. Those 2 respective planting dates usually correspond to a spring planting and a fall planting. That could very well be the only plantings you do for head lettuce in a season. However, you could subdivide those spring and fall planting dates into succession plantings. Say for instance you wanted to subdivide the early head lettuce planting dates into 3 smaller succession plantings. You could add a succession planting interval to the first planting date, then to the following planting date, and then to the third. This would give you 3 new planting dates for the head lettuce early category. I would then make sure this subdivides the total number of bed feet for early head lettuce and the total number of transplants to plant for each respective subdivision. You can use the succession calculator we discussed earlier to help you with this. The next thing you might want to do is to take the crop list, copy it to a new sheet, and bring over only the relevant columns you need to make a chronological calendar for things like greenhouse seeding dates, transplanting dates, or direct seeding dates. Make sure if you do this that you paste special into the new sheet so you can keep your formulas if you make changes later. Here's an example of a new sheet of information that was pulled from the master sheet we were just looking at. In this sheet, I've pulled over the crop list as well as the relevant columns that I would need to make a chronological calendar for field planting dates, greenhouse seeding dates, or whatever. To avoid confusion, you can make separate sheets for direct seeded crops versus crops that are transplanted. That way, you could have a list for the transplanted crops with the chronological order for the greenhouse seeding dates. For direct seeded crops, you could just have a list of the field planting dates. The way you organize the alphabetical crop list and the respective columns into chronological order is with the sort function in Excel. You highlight all the data, go to the Data tab on the top, then go to the sort function. And then you can sort by whatever column you want, whether you want a chronological list of the greenhouse seeding dates, field plant dates, or whatever. This is a useful way to organize all your different seeding dates. If you're uncomfortable working with spreadsheets, you can still do this all by hand, but the spreadsheets make the calculations much easier. Here's a chart that is specifically for planting in high tunnels. This is based on information from the Michigan State University Student Organic Farm, which is at 42 degrees north latitude. This is slightly further north than central Illinois. However, these dates are good enough to build planting spreadsheets just like the ones we previously discussed, but for high tunnel production specifically. This list has crops, varieties or cultivar, whether the crop is direct seeded or transplanted, seeding dates, transplanting dates, and also the approximate calendar dates. Building a spreadsheet based on this chart, coupled with the spreadsheets we previously discussed, is a simplified way to plan and manage multiple plantings throughout a whole calendar year, whether in outdoor production or in high tunnels. There are a couple other charts similar to this found in a link in the resource section. To summarize, succession plantings allow for a continuous supply of produce throughout the growing season. All of these techniques and concepts can seem complicated, but it's best to start simple with the major crop plantings first and work in the minor crops later. Then you can build succession intervals for filling gaps in open bed space and to address potential shortages. Keeping together records of greenhouse planting dates, field planting dates, harvest dates, and other pertinent data is the best way to fine-tune future successions for your farm and mastering the technique of scheduling succession plantings. Here are some resources that you can use to help you better understand succession plantings. These resources are links to websites that have some useful information. The first link is the Johnny Selected Seed website, Growers Library, that has lots of information about succession planting and the lettuce planting programs we discussed. The hoophouse.msu.edu link is the resource that has high tunnel crop schedules with planting intervals. The slide set that illustrates some of the complex succession techniques illustrates some of the more complicated things we discussed. Egg Squared is a cloud-based farm planning software that integrates succession plantings. If you have any questions, feel free to reach me at my email address, zgrant2@illinois.edu. Thank you, and good luck with the season.